Now we start our main course, and first part of our course is chemical thermodynamics. We know that most of energy which produced in our world in different processes is a result of combustion reaction. Actually, when we burn natural gas, oil, coal, and this process from heat position, from energy position, we study in such part called thermodynamics. Actually, when we analyze chemical reaction and different physical chemical processes, we have two methods, thermodynamics method and kinetic. And now our task to study thermodynamics position. So issue of energy change we study in thermodynamics, and thermodynamics as a science was formed in 19th century when scientist Carnot studied heat machine, and he investigated dependence between work, heat, temperature, so make physical dependence, but just then all physical positions, physical operations we put on chemical reactions, chemical process. So in our course we use physical laws, exactly physical positions in thermodynamics, but put in chemical reactions. So our course is chemical thermodynamics. And in chemical thermodynamics we need to solve three tasks. First, transfer of energy from one form to another. For example, a battery in different laptops or in mobile phones and smartphones. Here we have transformation energy of chemical reaction to electrical energy. And this is the first task of chemical thermodynamics. Then we need to calculate the quantitative measure of these reactions. So we need to determine energy effect, accompanying different physical and chemical processes, chemical reactions in different conditions, different pressure, temperature, and so on. But it's not enough just to know quantitative measure, to know how many heat we produce. But we need to know, is this reaction possible in given conditions? For example, we take two substances, place in one glass, and we make experiments in room condition. And before exact experiment, we need to predict, do this reaction possible? Or maybe we need to change temperature, we need to take pressure, or maybe we need to add any substance which we call catalyst. So third task of chemical thermodynamics is it possibility and direction of reaction, spontaneous reaction. So maybe we have forward reaction spontaneous or backward reaction, and of course we need to know limits of this process, of course in given condition. We said that in different parts of our course we are going to talk about different thermodynamic systems. In previous lecture we already studied what does it mean homogeneous reaction system and heterogeneous system, but now we need to discuss what does it mean thermodynamic system, which we use in chemical thermodynamics. It's a group of bodies, a group of substances which is related from environment, from surrounding area and object of our study. We have different types of thermodynamic system according to thermodynamic properties. So we have isolated system, when this system doesn't have the exchange with mass and energy with the environment, so all processes take place exactly inside this system. But in the world, we don't have a real isolated system. We have very close to them. For example, compressed gas cylinder or a seal ampoule, and etc. And in practice, in real life, we deal with closed and open thermodynamic system. What does it mean closed system? Closed system, the same like in isolated, we don't have exchange of mass, so mass of all system is constant, but now we have heat effect, we have exchange of energy. So energy can go out and come into the system. And of course, third type of thermodynamic system is open system. It means that mass and energy of the system don't constant, so we have exchange both exchange of energy and exchange of mass with the surrounding area. Okay, thermodynamic system. Now I'm here in the class and you're sitting in your rooms, and we can say that we are all in thermodynamic system. And of course we can describe this system, but what we use to describe it? We need to classify chemical thermodynamics properties, thermodynamic characteristics, and we have two groups. First, thermodynamic parameters. Here we use pressure, volume, concentration of different solutions, temperature, mass of exact substances. These parameters, simple parameters, independent characteristics, but we also use second group of properties, thermodynamic functions, which depends exactly on thermodynamic parameters. So we can say that thermodynamic functions, complicated characteristic, and here we have work, heat, entropy, enthalpy, internal energy, Helmholtz energy, and Gibbs energy. But thermodynamic functions as well, we can classify it into groups, just functions and thermodynamic state function. You see these red functions with written in the slide: internal energy, enthalpy, entropy, Gibbs energy, Helmholtz energy. They are exactly thermodynamic functions of state. What does it mean? In our course, in course of chemistry, mostly name of different parameters as well give the meaning of this physical meaning and chemical meaning of these parameters. So thermodynamic state function obviously is a function which doesn't depend on the way of chemical process, but just depend on a state of this system, initial state and final state. I mean, we just need to know which parameters we have in our system, I mean pressure, temperature in initial position and final position, and of course which reactants we have and which products give us this reaction. But this process exactly for thermodynamic function doesn't necessary. Well, as well, we can classify, we can divide such properties into two groups according to dependence on the mass of these substances. First, we have extensive, which exactly depends on a quantity of substance, volume, enthalpy, entropy, and so on, and intensive, independent properties, independent on quality of substance, quantity of substance, I mean electrical potential, pressure, temperature, and etc. But of course, as you already understood, all processes all systems always change, and in this situation we have thermodynamic process. Thermodynamic process, I mean, is a change of system state, which characterized by change at least one of thermodynamic parameters. We have three types of thermodynamic process. Spontaneous. What does it mean, spontaneous? Such processes goes without any force from outside. So we take two different substances and we see reaction between them in given conditions. For example, combustion reaction, we can say that it's a spontaneous process, corrosion reaction, dissolution process, and so on. Of course, sometimes, as you already understood, we need to change parameters, and in this situation we have non-spontaneous reaction. For example, we need any catalyst, and just in this situation reaction goes. And we have cycle. What does mean cycle from thermodynamic point of view? Then our system, thermodynamic system, left its initial position. So we have any change in temperature, pressure, heat change, but finally at the end of our reaction, at the end of process, thermodynamic process reaction come back to initial point, initial position, initial state. And as well we need to remind that depends on different thermodynamic parameters, and this amount. We have isochoric process when volume is constant, isobaric process, constant pressure, and isothermal process which goes under constant temperature.